objects A and B with masses m1 and m2 separated by a distance d, then the gravitational force between them is given by this formula. And uppercase G here is called the universal gravitational constant, and its value is approximately equal to 6.673 times 10 raised to negative 11 Newton meter squared per kilogram squared. The gravitational force is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This is the universal law of gravitation. Now let me assume that you're looking at this video at home on your computer. So if any two objects attract each other, why don't you get pulled to the computer, or why doesn't the computer get pulled towards you? The answer is pretty logical. It's not only you and your computer in the picture. There are other forces acting on you and the computer. Take the gravitational force of the Earth, for instance. It's pulling you as well as the computer so strongly towards itself that the force between you and the computer is negligible compared to it. Also, there'll be force of friction, which is much more than the gravitational force between you and the computer. You will also get the answer by looking at this formula. The value of the universal gravitational constant is very, very small. To calculate the force between you and the computer, m1 and m2 will be your mass and the computer's mass respectively. But if you calculate the gravitational force between you and the Earth, or the computer and the Earth, then one of the masses will be the masses of the Earth, which is massive as compared to the other two masses. Which is why the gravitational force pulling you and the computer down is much, much bigger than the force pulling you two towards each other. So if you and your friend are standing next to each other on Earth, the gravitational force between you two will not propel you towards each other.